Hi everyone, welcome to the AI Digest Weekly, and today we'll be looking at week 11, starting from March 13th to March 19th. We're going to be looking at the top 10 AI research papers covering the domains of large language models, computer vision, and NLP. Hi everyone. So the first article we are going to be looking at today is called Vid to Avatar, 3D avatar reconstruction from videos in the wild via self-supervised scene decomposition. Now, as it's evident from the name, digital avatars are becoming increasingly popular and integrated into our daily lives. As you're aware, the full body digital avatars have a great potential for use in video games, virtual reality, robotics, and movies. Now, the problem is that the generating high fidelity 3D avatars requires very, very specialized equipment, but this whole process has been simplified, by this new tool called the Vid2 Avatar. Now, what this tool does is it uses neural fields to separate the input picture into the background and it extracts out the human subject from the background, and then what it does, it processes each one of them separately. And so each of these, the background and the human picture, are adjusted separately, and then they are combined again at the end, and the picture is reconstructed. Hi everyone, let's look at the next article. It's called Prompt, Generate, then Cache. Cascade of Foundation Models makes strong few-shot learning. Now, what researchers have done is they've created a new approach called CAFO, which is a cascade of foundation models for few-shot visual recognition, where a network learns from a limited number of annotated images. So what we are doing here is the CAFO, it learns from 4 different pre-trained models, which are GPT-3, Clip, the Dino or the Dino model, and the DALI model. Now, what each one of them does is that, like, the GPT-3 provides the language generative knowledge, the Clip provides the language contrastive knowledge, Dino provides the vision contrastive knowledge, and the DALI provides the vision generative knowledge. So what this CAFO system does is it takes the inputs from each one of these systems, and then it generates more training data, adaptively integrates the predictions which are coming out of each of these systems, individual pre-trained models, and then improves the overall model's generalization capabilities. Now, as you see here, CAFO has achieved the state-of-the-art results on 11 different data sets on few-shot classification, and without using any additional annotated data. The next article, it's called MATHPROMPTER, Mathematical Reasoning Using Large Language Models. Now, we all understand that the language models, they struggle with the arithmetic reasoning task or any kind of mathematical operations. They often produce incorrect responses, which makes it difficult for the users to trust their results, right? Now, the scientists have proposed a new AI-powered tool called MATHPROMPTER here. Now, what this MATHPROMPTER does is it enhances the performance of the large language model on mathematical problems. Now, what the MATHPROMPTER does, it uses the zero-shot chain of thought promoting technique. And what essentially it does is it takes the input query, converts that into an algebraic template, and it solves that problem in 2 different ways. It solves it as an algebraic prompt, and it also solves it as a Python function. Now, why it does it is that then it compares the output of the algebraic prompt and the Python function, and that difference improves the statistical significance and improves the confidence of the machine in making the correct answer. Look at the next article. It's called Semi, a meta-learning approach for semi-supervised learning. Now, the problem statement is that the hyperparameters, optimizing the hyperparameters for semi-supervised learning algorithms can be very hard and unreliable because of very scarce annotated data or the label data. Now, researchers from the Tsinghua University have introduced this approach called meta-semi. Now, what this approach does is it produces pseudo-labeled data from the unlabeled data using network predictions. And then it removes the samples that are unreliable and it trains a model on the remaining data that is left over. Now, when they have these pseudo-labeled samples, they then do use a dynamic weighting approach to provide a higher weight to the samples that have been pseudo-labeled. The eventual goal is to reach the stationary point of the supervised loss function. Now, it has been seen that this meta-semi algorithm has outperformed all of the state-of-the-art deep networks and semi-supervised learning algorithms for image classification such as C410, C400, ASV, HN, and the STL10. The caveat is that the meta-semi algorithm does require a little bit more time to train, but that is an area of future improvements. It's called the wisdom of hindsight makes language models better with instruction followers. Now, the problem that we're trying to solve here is that the large language models can generate fake information, toxic text, or not follow instructions as desired, raising ethical concerns, as we have seen. The reinforcement learning, that is the algorithm that I use to train the large language models, can tackle some of these issues, but it requires a lot of training. Now, hindsight instruction relabeling HIR is a new algorithm that has been proposed in this paper that improves the large language models and aligns them better with the human instructions. Now, the HIR consists of two phases. It's called the online exploration phase, which is here, the online sampling, and the offline training phase here. Now, what the model does is it uses the successful and the failed instruction output pairs from each of these two phases. It keeps alternating between these phases, and it takes the successful and the failed instruction output from these two phases, and it converges them or combines them together so that the LLMs improve the alignment with the human instructions. Now, the HIR technique or the hindsight instruction relabeling technique does not require any additional reinforcement learning, but it has been seen to outperform all the baseline models in the various reasoning tasks that it works in. The next article is called PETALS. It's a collaborative inference and fine-tuning of large language models. Now, the problem here is that the large language models, which are 100 billion parameters or more, there are quite a few of these models that have come up, but their use often remains challenging due to the memory and the computational expenses that these models have. Now, offloading these model parameters to an affordable memory can democratize LLMs, even though it will have very high latency issues. So what this paper introduces this concept called as PETALS. Now, this concept is around online collaboration, which essentially means that the models are all hosted in the internet, and the PETALS framework provides techniques such as dynamic quantization and load balancing and compression, so that and it also provides a method for reliable routing, so that the clients that have a use case that needs to be solved using a large language models can be routed to the various servers that are there on the internet, and the inferencing can be provided in a collaborative manner. This article is called Alpaca, a strong replicable instruction following model. Now, the problem is that the training high quality instruction following models requires a very powerful pre-trained language model and abundant high quality data, which can always be very expensive. The recent studies from the Stanford Human Centered Artificial Intelligence has released a model called Alpaca. Now, this is an instruction following model. It is based on the Meta L Llama 7 billion parameter model. Now, it exhibits the same behavior as the OpenAI's Text Da Vinci model. And the Text Da Vinci model here is a 175 billion parameter model, as you're aware, as compared to Llama, which is only a 7 billion parameter model. Now, what the team has done is that they have created a data set of 52,000 unique instructions and their output for under $500, and using the OpenAI API and the Hugging Face training architecture and methods. And it has been found that this model, Alpaca model, performs as well as the Text Da Vinci 003 model, but it still has the same shortcomings related to delusion, toxicity, and stereotyping. The next article is from Microsoft. Now, this research paper, the name of this research paper is Speak Foreign Languages with Your Own Voice, Cross-Lingual Neural Codec Language Modeling. Now, the problem with these traditional text-to-speech models have been that they always produce these robotic sounding outputs. But the introduction of the deep neural networks has led to more of a human-like and natural sounding speech. Now, what Microsoft Research has done is they have developed this cross-lingual neural codec language model called Valley-X. Now, this can transmit a speaker's voice from one language to another, overcoming the foreign accent problem. Now, what this does is this Valley-X cross-lingual model does it. It uses the in-context learning framework, to produce cross-lingual neural codec language model. Now, this predicts the acoustic token sequences of the target language speech by using the inputs as the source text, the source speech, and the target text. By using these inputs, it produces an acoustic token which is in the language of the target. Now, the Valley-X has been evaluated with both with English and the Chinese languages using the LibriSpeech and the eMime datasets, and it has demonstrated high-quality, zero-shot cross-lingual speech synthesis performance. The article is called Phone to Proc, Bringing Robust Robots into Our Chaotic World. Now, the embodied AI, it enables physical objects to move through the real world and interact with it physically. Now, previous studies have shown that deploying agents trained in a simulation to the actual world is very laborious, and it does not always produce the expected results. Now, phone to proc is an approach where it's a lightweight approach where a user could take a scan of a location using his cell phone. So he takes a phone scan, and then with the phone scan, the phone scan is taken using the Apple Room Plans API. Once we get the room scan, an environment template is created out of that room scan, and then there are different variations that are made. Scene variations that are made into that room plan. These scene variations could be changing in lighting or some movement. So these scene variations are performed, and that is used for simulated training. Those scene variations are used for simulated training, and then the model is produced, which is very much similar to a real world deployment. Right. Now, this phone to proc system is resilient to various kind of scene disturbances that can occur, like crowded spaces, movement of target objects. It is also resilient to all of those requirements. Article for today is named Meet in the Middle, a new pre-training paradigm. Now, the problem statement here is that the most large language models, they predict the next token based on the previous token, but they ignore the following tokens during the pre-training. Now, what Microsoft researchers have done is they have proposed a combined pre-training and inference paradigm, which is called Meet in the Middle, MIM. Now, what this does is it uses two different language models. Here, the language models, they read the tokens in the opposing direction. So this language model, it is reading the tokens in this direction, and this second language model is reading the tokens in the other direction, right? Now they co-regularize each other to increase the effectiveness and the consistency of the data. The primary contribution of this meet in the middle model is that it includes both the prefix and the suffix for the pre-training, so which results into a very quick and effective inference process, and that is outperforms most of the baseline models in the common evaluation criteria. So guys, that's a wrap for today. Thank you very much for joining me, and I look forward to meeting you again next week with the top 10 research articles. Thank you.